Good morning, good afternoon, good evening, and good night, children. Whatever time you are watching. Today, I am going to discuss about a very important chapter. This chapter is in your class 10th CBSE and always also in state syllabus. Chapter 4, Carbon and its Compounds. Very important chapter if you want to pursue your career in the science field. In the PCMB or PCMC combination, chemistry part will be there. In that chemistry part, this basics what I am teaching today, this chapter plays a very important role. Many of the class 11 students don't know how to write the compounds, many of the organic compounds. So this chapter will help you a lot to be very good in your basics. So let's start. I'll teach you pin to pin all the basics in an easy manner, and I'll teach you how to write the answers, how to tackle the questions. So everything will be dealt very easily. If you like this video, please like it, share it with your friends, subscribe to the channel. Every points, whatever will come to the board exams will be dealt in an easy manner, very easy manner. Okay, let's start. So we'll start with the introduction. Coming to the introduction part, see children, carbon plays a very important role in our daily life. See, whatever food, clothes, medicines, everything, whatever you are eating, rice and everything, no, it is organic compound. Organic compound means mainly carbon should be there. Organic means itself it is a compound. Previously and all, it was felt like organic compounds are only derived from the living resources like plants and animals. Later, it was made false that even organic compounds can be made. That I'll explain you later. So, organic compounds entirely it depends upon carbon. Carbon should be present. So, coming to the introduction, in the earth crust, in the earth crust, carbon is present only 0.02%. In the earth crust, carbon is present only 0.02%. Next, this is present in the form of minerals. Whatever 0.02% is there carbon, it is present in the form of minerals. What are the different minerals? Carbonate, CO3 2 minus, carbonate ion. It is an anion. Next, bicarbonate ion. Next, it is also present in the form of coal and petroleum. Okay, these are the different forms of carbon in the earth crust which collectively forms about 0.02%. Next, in the atmosphere, only 0.03% of the carbon is present, that too in the form of carbon dioxide. See, so much less percentage of carbon is present, even though so much less amount of carbon is present in the entire earth crust and atmosphere. Nearly you can say 5 millions of the carbon containing compounds are formed. Okay, and for example, in the previous class and all, you have studied about carbon dioxide and all. These are inorganic compounds. You can say these are inorganic compounds. Oxides of carbon, allotropes of carbon, these are inorganic compounds. Not all the carbon containing compounds are organic. Try to remember, try to understand, children. Oxides of carbon and allotropes of carbon, all these are inorganic only. They are not organic. Fine. Next, we'll study about the bonding pattern. How will be the bonding? How will be the bonding in carbon? Coming to the carbon bonding, carbon will form covalent bond. Carbon will form covalent bond. What is covalent bond? It is the sharing of electrons between the participating, or else sharing of electron between the bonding atoms. Bonding atoms, there will be sharing of electrons. Such type of bonding, we call it as covalent bonding. Example for this covalent bonding is H2, CH4, CO2. In all these compounds, there is a covalent bonding. Hence, the compounds or the molecules are known as covalent compounds. These are known as covalent compounds because they have a covalent bond in it. Fine. Now, we have to study the characteristics of covalent compounds. Characteristics of covalent compounds. What are the characteristics of covalent compounds? First one, they usually exist as liquids and gases. They usually exist as liquids and gases. Next point is they are poor conductors of electricity. They are poor conductors of electricity. Why it is called poor conductor of electricity? Because to conduct the electricity, either free electrons should be present or else ions should be present. For example, when you take ionic compound, NaCl is an ionic compound, MgCl2 is an ionic compound, AlCl3 is an ionic compound. When it is dissolved, when you add this compound in your water, they undergo ionization into Na plus and Cl minus. They will conduct electricity. But in the covalent compounds, neither they have free electrons nor they have ions. So, they are the poor conductors of electricity. Second point. Next, they have low melting point and boiling point. They have low melting point and boiling point. Why it is called low melting point and boiling point? Consider, children, covalent bond is a strong bond. It is not a weak bond. But why melting point and boiling point is low? You know that ionic compounds, for example, Na plus Cl minus, there is an electrostatic force of attraction. Since there is a strong force of attraction, they have a high melting point and boiling point. Ionic compounds have high melting point and boiling point. Fine. But in covalent compounds, see here what is melting point and boiling point. For example, what is boiling point? There is a liquid here. In the liquid, the molecules will be like this. Fine. When you boil it, the molecules become far. You have to make the molecules far. You have to make the molecules far. If it requires more energy, high boiling point. If it requires less energy, low boiling point. For example, see here what happened. This is one molecule. This is one molecule. Hydrogen molecule. Okay. This bond is covalent bond. Try to understand, this bond is covalent bond. But in a gas, there is a weak force of attraction between these two molecules. This force, we call it as van der Waals force of attraction. Van der Waals force of attraction. This force, it is called as weak van der Waals force of attraction. Since the force between the two molecules is very weak, you require less temperature or less energy is required to break this. Less energy is required to break this. You can separate easily. You are not breaking this. You are separating here. So only you are having low melting point and boiling point. Fine. Next, we'll talk about the valency. These are the three characteristics. They either exist as liquids or gases. They are the poor conductor of electricity because neither they have free electrons nor the ions. Next, they have low melting point and boiling point. Fine. Hope it is clear. Next, you'll be studying about the valency. The combining tendency of an element. For example, carbon will form 4 bonds. So, its valency is 4. Hydrogen is making only 1 bond. Hydrogen valency is 1. Oxygen is making 2 bonds. Oxygen valency is 2. So, the combining capacity of an element, we call it as valency. Now, we'll study about the valency of the carbon, why it became 4. Okay. What is the atomic number of carbon? Atomic number of carbon is 6. Electronic configuration in terms of orbitals is 1s2, 2s2, 2p2. Fine. Now, electronic configuration in terms of shells. KLA, first shell is K shell. How many electrons? 2 electrons. L, second shell. Second shell, how many electrons? 4 electrons. There are 4 electrons in the valence shell. This is very important. This inner electrons not important. Whatever chemical reactions you will see, this is because of the valence electrons. It is having only 4 electrons. It requires 4 more electrons to attain octet. What is octet? Octet rule says that any element will be stable if the valence shell has 8 electrons. It has only 4 electrons. It requires 4 more electrons to become stable. Except hydrogen. It is happy with 2 electrons. Because if 2 electrons is present, it becomes helium. It attains helium electronic configuration. Fine. You try to understand. Now, carbon requires 4 more electrons to become stable. Fine. Now, why it will form? Next question. Why it can form ionic bond? No, why it is making covalent bond? See, consider one condition, that it is accepting 4 electrons. See, ionic bonding means there should be transfer of electrons. One is giving the electrons, the other is taking the electrons. One is giving the electron, the other is taking the electron. There is a transfer of electrons. Consider that carbon has taken 4 electrons. See, atomic number 6 means carbon has 6 electrons and 6 protons. Atomic number 6 means, see, this is the atom. These are 2 shells. These are the 2 shells. Fine. In the nucleus, there are 6 protons. There are 6 protons in the nucleus. In the first shell, there are 2 electrons. In the second shell, first shell, there are 2 electrons. First shell, there are 2 electrons. In the second shell, there are 4 electrons. 2 plus 2, 4 electrons. Fine, 4 electrons. Total 6 electrons. But in the nucleus, how many protons are there? In the nucleus, there are only 6 protons. Now think that it has taken 4 electrons. Already 6 electrons is there by itself. It is taking 4 electrons. Total 10 electrons. Do you think that 6 protons in the nucleus can hold 10 electrons in its shell? Can 6 protons hold 10 electrons in its nucleus? No, it is not possible. It becomes unstable. So it cannot accept 4 electrons. Second condition. Think that it will give 4 electrons. Means it can give this 2 electrons. 4 electrons it can give. It can become helium electronic configuration. 1s2, no, it can become stable. To remove 4 electrons from this system, from this atom, it requires large amount of energy. So it is difficult to remove 4 electrons from this atom. So neither it will take electrons nor it will give electrons. So carbon will decide that I will share the electron so that I'll attain octet. It will share the electron to attain octet. I will show you how the sharing will occur. If there is a sharing of electrons, what type of bond is formed? Covalent bond. Correct? And always remember, only valence electrons will participate in the bonding. Only this 2 plus 2, 4 electrons. Children, try to understand, this is the shell number. 1, 2, 2, this is the shell number. Second shell, how many electrons? 4 electrons. So this will participate in the bonding. Children, next we'll study about the electron dot structure. Electron dot structure of molecules. Electron dot structure of molecules. See, in the chapter metals and non-metals, you have studied about the electron dot structure of the atoms. I'll recall that. For example, if you take hydrogen, atomic number 1, what is electronic configuration? 1s1. How many valence electron? 1 valence electron. That you will mention here in the form of dots. If you take helium, atomic number 2, 1s2. Only valence electrons you have to show. 2 electrons you will show here. Helium, no? Like this. If you take sodium, atomic number 11, 1s2, 2s2, 2p6, 3s1. In the valence shell, there is only one electron. In the valence shell, there is only one electron. So I'll write it as sodium like this. Anywhere you can put the dots. And this is the electron dot structure of atoms. Now we'll talk about the electron dot structure of molecules. These are for atoms. Next, electron dot structure for molecules. First, we'll start with the hydrogen. I'll teach you how to remember the electron dot structure very easily, very easily. See properly how to start. If they ask, write the electron dot structure for H2 molecule. How to write? Always remember, between the hydrogen there is one bond. Okay, I am teaching you in the reverse method. Usually after writing the electronic dot structure, they will write the bond. You remember, children, this is easy. Hydrogen will have one bond. Hydrogen, between hydrogen, one bond will be there. Okay, hydrogen has no lone pair of electrons. What is lone pair of electrons? For example, oxygen will have dots like this, extra dots. These are known as lone pair. One lone pair, two lone pairs. So total two lone pairs, 1 1. Okay, this is pair, lone pair. So how to write the electron dot structure? Write hydrogen, one bond means two dots. Write hydrogen. I'll explain you how you got this. And circling is very important. Step 1 is one bond means write two electrons. Second step, just circle for two electrons, because hydrogen is happy with two electrons. It doesn't have octet. It has duplet. It is happy with the duplet. See here, for this also give two electrons. How is it? See here, hydrogen electronic configuration is 1s1. It requires one more electron to become stable. So what this two hydrogen will decide? They will decide that we will share. This two electrons belongs to this also. This two electrons belongs to this also. Clear? It is like this is having rice, this is having curry. So they share it, they mix it and eat rice and curry. Both belongs to both. Now both are happy. This also is hydrogen 1s1. This hydrogen is 1. This hydrogen is 1. This is the valence electron. It is sharing. Like this you will write the electron dot structure for hydrogen. Second one, how you will write for oxygen? Always remember, oxygen will have a double bond between it. And whenever oxygen is having two bonds, it will have two lone pair electrons. Don't forget this. Now write the electron dot structure. One bond means two electrons. One more bond, two electrons, oxygen. Write the lone pair of electrons. Oxygen will have 4 electrons around it. 2 plus 2. 2 plus 2. 4 electrons. You have to circle that oxygen will get 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. Circle neatly. Chemistry means you have to write neatly, children. Circle it. Next, 1, 2, 3, 4, 5, 6, 7, 8. Circle it neatly. Done. This is the electron dot structure for oxygen. Fine. Next, how you got this? See here, one oxygen I'll write here. 1s2, 2s2, 2p4. 8 atomic number. 1s2, 2s2, 2p4 for this oxygen atom. It requires 4 more electrons. Correct? 4, 5, 6, 7, 8. It requires 2 more electrons. Sorry, it requires 2 more electrons. No, for already 6 is there. 2 plus 4, 6 is there. So it requires 2 more electrons. So it will share 2 electrons. See, 1, 2, 3, 4, 5, 6. Already 6 is there. Valence shell, 2 plus 4, 6 is there. It requires 2 more. So it will share 2 more. Okay. After sharing, it will get all the 8 electrons octet. Clear? See, it requires, for example, here 2p5 is there. 2p5 is there means it requires 1 electron. 2s2, 2p5 means 7 is there. Already it requires 1 more electron. Like that. Next, third one, nitrogen. Nitrogen, after making triple bond, it will have 2 lone pair electrons. 1 2 1 2. Never forget. Oxygen ge 1 2 3 4 1 2 3 4. Nitrogen ge 1 2 1 2. Done. Now how to write the electronic electron dot structure? Nitrogen, 1 bond means 2 electrons, 2 second bond, 2 third bond, 2. So total this plus lone pair of electrons, 1 2 3 4 5 6 7 8. Just circle it. This nitrogen got 8 electrons. 1 2 3 4 5 6 7 8. This also got 8 electrons. So this is the electron dot structure for nitrogen. Next, electron dot structure for carbon dioxide. How is the structure of carbon dioxide? Try to remember. If you write the electronic configuration and sit, it will be difficult. Just remember the structure: carbon, double bond, oxygen, double bond, oxygen. Oxygen always will form double bond, majority. Okay. Then after this, you have never forget the lone pair of electrons. Naak baribekalva, you have to write 4 lone pair of electrons. You have to write 4 lone pair of electrons. Then what you have to do? Write carbon. Then how many bonds? 1 bond, 2 bond. Oxygen, 1 bond, 2 bond, oxygen. Lone pair of electrons, never forget, never forget. Okay, just to circle it. 1 2 3 4 5 6 7 8. This also got 8. This also got 8. So this is the electron dot structure for carbon dioxide. Next, fifth one, ammonia. Ammonia. Anything you have to write very neatly. Chemistry means you have to write neatly. Don't scribble in the books. It has to be neat. Okay, nitrogen. Nitrogen. Nitrogen always will have 1 lone pair. Lone pair means 2 electrons will be there. Oxygen will have 4. 1 2 3 4. Nitrogen will have 2. With that 3 bonds it will have. 1 2 3. Why I have written ammonia like this, not like this? Because in higher classes you will study that this is not the structure. This is not the structure. This is the structure. It will have pyramidal structure. You will study in class 11. You write like this. You remember, ammonia has pyramidal structure. Common examples only they will ask in class 10. How to write the electron dot structure? Write nitrogen, 2 dots. How many bonds? 1 bond, 2 bond, 3 bond. Hydrogen, hydrogen, hydrogen. Now circle it. 1 2 3 4 5 6 7 8. Including all, you circle very neatly. Children, don't scribble in the answer sheets. It should be presented very neatly. Then this, then this. Done. Now coming to which one? Methane. We'll write the sixth one. We will write the electron dot structure for methane, and this will have the structure called tetrahedral structure, like this. Remember children, you can remember tetrahedral structure. No lone pair of electrons on carbon. No lone pair. Lone pair means, hope you know, extra dots you will put. No, that is not there. For nitrogen, 2 dots you will put. For oxygen, 4 dots up to down to. Means total somewhere 4 dots you will put. How you will write the electron dot structure? Write carbon here. 1 2. 1 2. 1 2. 1 2. 4 bonds over, no. Write hydrogen like this. Then put a circle mark. Put a circle mark. Put a circle mark. Put a circle mark. And put a circle mark including all the 8 electrons for the carbon. Fine. Count 1 2 3 4 5 6 7 8. But hydrogen, it is happy with 2 electrons. Only 2 for hydrogen. Fine. Now next, last one I will do. Then chlorine. Remember, chlorine, no, it will have 1 bond with it. Between chlorine, only 1 bond. How to write chlorine? See here. Always remember 1 bond, no. You have to write 6 electrons around it. Always chlorine, fluorine, bromine, iodine. You have to write 6 electrons around it. Then circle it. 8 electrons should be there in the circle. Circle it. 8 electrons should be there in the circle. And I'll give you the shortcuts. Listen here. Around oxygen, how many lone pair? Lone pair, how many lone pair? 4 lone pairs. Lone pair electrons, lone pair electrons. Pair means 2 pairs. Clear? Nitrogen will have 2 electrons, 2 dots you have to write. And sulfur will have 4 electrons total. 4 means 2 pairs. Chlorine, bromine, iodine, fluorine. These all will have 6 electrons around it. Along with the 4 electrons, it will have double bond. Double bond. Along with the 2 lone pair of electrons, it will have triple bond. Triple bond. Common examples I am giving you. Okay. Sulfur will have double bond. Double bond. This will have single bonds. Single bonds. Okay. Try to remember the children. See here. Oxygen will have 2 bonds. Oxygen will have 2 bonds along with 4 electrons. See, this is easy, children. Very easy to write the electron dot structure. Now, last concept I'll teach you, which is not in your textbook, but still it is important. In covalent bond, there are 2 types, children. One is polar covalent bond. The other one is non-polar covalent bond. Okay. In the polar covalent bond, for example, take HCl, hydrogen chloride as an example. Okay. One bond means there are 2 electrons here. Now, chlorine is more electronegative than hydrogen. Chlorine is more electronegative than hydrogen. Now, you'll ask me, ma'am, what is electronegative? Means, electronegativity means tendency of the element to attract the shared pair of electrons towards itself. See, there is a shared pair of electrons. What this chlorine will do, it has more tendency compared to hydrogen to attract the shared pair of electrons towards itself. Now, how the hydrogen, how the electrons will be there? It will be like this. It will not be in the center. So, as a result of this, this will carry delta negative, partial negative charge. Partial negative charge. This is not ionic bond, this is covalent bond only. Because of the difference in the electronegativity, they will have partial negative charge. This will have partial positive charge. Hence, they will have a polar covalent bond. What type of? There is a polarity, right? Polarity means charge separation. There is a positive charge, here there is a negative charge. This type of bond, we call it as a polar covalent bond. For example, take H2 molecule. How is the H2? Hydrogen is there, hydrogen is there. Who is more electronegative? How can you say this hydrogen is more? Both are same. So, that case, the shared pair of electrons will lie in the center. This type of bond where there is no polarity, there is no poles, positive, negative poles are not there. This type of poles, it is called as, this type of compound, we call it as non-polar covalent compounds. Non-polar covalent compounds. Now, I'll give you the list of polar compounds. Polar compounds, example, H2O, HCl, common examples. Non-polar covalent compounds, H2, N2, Cl2, homonuclear we'll call it as. We'll call it as homonuclear or homoatomic. We call it as same. These are all will be, there is no difference in electronegativity. So, they will have non-polar covalent compounds. Next, oxygen, then Cl2, then CH4. Methane is a non-polar compound, non-polar covalent compound. Bonds may be covalent, but you remember it has a non-polar covalent compound. Carbon dioxide, non-polar covalent compound. Benzene, you'll study what is the structure of this. This is the structure you will study. This is the benzene. This is also non-polar covalent compound. Clear? Now, hope the concept is clear. Try to understand how to write. I have teach you shortcut method. Like, first write this. You will get to know oxygen, between it will be a double bond. Nitrogen, there will be a triple bond. Then one bond means write 2 dots. It will be easy. This concept is very important. In the next class, I will be teaching you about allotropes of carbon. what are the allotropes of carbon, what is the versatile nature of carbon, and all very important topics I'll be explaining. Today's homework is try to write the electron dot structure for HCl. Fine. For this hydrogen, no lone pair of electrons, you'll be sharing one bond, and chlorine, you will write 6 electrons around it. You try. Okay, next class we'll meet. If you like this video, please subscribe, like, share with your friends. It will be very useful. Step by step, neatly I'll be teaching you. Just subscribe to my channel. Thank you, students.